Okay, so hello guys. So it's a great pleasure to present the final speaker of today's session. And this is Dr. Arkadiusz Wisniowski from the University of Manchester. And he will speak about measuring migration stocks using traditional and social media data. So please.
Thank you very much, Eugene. And thank you so much for the invitation to present at this school. It's a great honor and pleasure. So my name is Arkadiusz Wisniowski. I come from as Eugene said, from Social Statistics Department at the University of Manchester. So maybe let me introduce myself very briefly. I'm not a mathematician. I hold a PhD in economics, and my department is also a social statistics with a highlighting of the social part of the name of the department. And my research interests actually diverge slightly from economics into more statistical applications and developing methods or applying statistical methods to estimate human migration, forecasting of populations, and integrating data from various sources to achieve those goals. And I show you some motivation and introduction about why I believe this is an important topic that I'm pursuing in my research. Sorry. Yeah, so today I prepared a lecture in which you will learn about a particular application of statistical methods with a focus on Bayesian inference in social sciences, or demography, if you like. So demography is measuring of the populations. We will learn something about international migration data and from traditional and new sources and new forms of data. So there will be some data science elements here. And also I will show you how this Bayesian inference can be used, or Bayesian or probability theory can be used to represent uncertainty about things that we want to learn about, but we don't have any particular knowledge about. Feel free to interrupt me, or I don't know what's the kind of typical way it's done here, but
Arkadiusz, typical way. So sometimes if there are urgent questions, the students can write in chat, or they just can raise their hands or just say a question. And otherwise, if the question is not urgent, then the students please wait till Arik finishes, and then you'll have a lot of time to ask the questions.
Excellent. Thank you. I actually should say that I highlighted here application because this work is very applied. I actually don't have that many equations for you. I will rather, when I'm teaching, I usually focus on telling stories, and actual equations are somewhere in the paper. So I have a few papers for you at the end of the lecture where you can reach out. But I will try to explain things in a bit more thoroughly than normally I would do with those problems. So yes, I will not show you too many equations, so it's not very technical presentation. Rather, I would like to show you how the topics that you're learning in your undergraduate and perhaps in your further studies may be applied in real-world applications, and actually bringing the various disciplines from social sciences, from demography, from mathematics, from statistics, and computational science, or data science. Yes, so, okay. Why is jumping here? So let me give you some introduction. Why migration is important. So I don't know if you are interested in a current debates, in a public debates about migration or about situation in the world, but the international migration has been on agendas of public debate for quite a few years. You may recall. I think I have something wrong with my mouse here. Sorry, apologies for that. It has been on the public agenda for quite a few years, especially when we look at the changes in the population of the UK, for example, where this is a comparison of the international migrants living in the UK between 2001 and 2015, and we see that between these 2 years, in over 14 years, for example, the increase in the number of Polish migrants residing in the UK has been about 20-fold. It reached almost 1 million of persons in 2015. Romanian nationals or Lithuanian nationals had even larger relative increases, although not that much in absolute terms. But that shows that this has been a very dynamic process in the population. Also, as you can see, this is a poll tracker. This is a survey done by Ipsos Mori, and showing the issues that what is the major issue faced by Britain today. And as you can see, in 2015, 2016, immigration was the most important issue. Yeah, when the so-called Brexit referendum happened, it slightly diverted, and actually the EU and Brexit became more important. However, this is still an important issue, for example, for the 2019 elections, and widely debated. This is news just from, I think, yesterday. Record 430 migrants cross English Channel in a single day. We can see those news every now and then on BBC or any other outlets. That it poses some issue for the public debate, for the government, or for the wider public as well. Also, you probably have heard that some countries and some politicians would like to build walls to stop migration because they do not like it, and they would like to introduce some policies, some policy measures. For example, well, building a wall is quite extreme, but it can be a quota issued on the number of migrants, or for example, preferring a skilled migration rather than unskilled migration. Also, there are some arrangements, some policies, such as the European Union and the Schengen Agreement and the freedom of movement, where people are free to move between countries. So this is a border between Netherlands and I believe Germany, and it is just a line on the road somewhere in the forest, and people can move between countries for the purpose of employment, for the purpose of residency. They don't need to have any special permits for that, such as a visa or residence permit. So why do we need, so in this context, we need data on migration. So why do we need this data? Because first we want to assess what's the population size and structure. From demography, we know that mortality and fertility are not that volatile, except for the very recent case of the COVID pandemic, which introduced some volatility. The major population change component is international migration, and structure is impacted heavily by the internal and international migration. It has also societal, cultural, and economic impacts, such as, for example, on the labor market, a huge influx of Polish migrants, for example, to the UK. We need data to detect sudden changes in trends. So if you want to implement some policies, tackle those problems, such as the migration crisis during the Syrian civil war. And then we want to design and evaluate these policies, and we need to have data. If we design policies that I would like to cap migration or reduce migration, we would like to assess and evaluate whether that indeed happened. However, what are the data? So this is just very broad picture here, because I know that your background is not in demography. Migrant stocks data, so how many people live in a given country, how many migrants live in a country. These data are quite reasonably well available. They are available for all countries in the world and areas. However, they mainly come from censuses, and censuses happen every 10 years, or for some countries every 5 years. Only very few countries have that. The flows data, which is actually measuring the actual dynamics of what's happening in migration, they are provided by 45 countries, and these are mostly the developed countries. So this is the flow from A to B, from B to A. And also for those countries that actually provide those flow data, we don't know, these data are not as great as we would wish them to be. First, they differ in definition of who is a migrant and, and what is a migration. I will show you another slide on that to illustrate that. Then we have a coverage. So imagine that you would like to measure migration, measure number of migrants in a target population, like entire population of your country, but you only cover a portion of that. For example, you may neglect completely returning nationals. So, for example, British people coming back to the UK. They are in fact measured, but some countries such as France or Romania, they do not consider these people migrants, but they still change the population size and have impacts on the population and society. Then there's underreporting or bias, where people do not, for example, register, or they register from the population registers, or they are not captured in some, because of some reasons, for example, because they cross borders without without the permit, without reporting to the authorities. Very important issue here is underreporting when people leave a country. They do not deregister from the population register. So for example, I am Polish. I came to the UK in 2009. I had a 2-year contract then, and I told the Polish authority that I'm leaving for 2 years. However, to be considered an emigrant from Poland, I would have to say that I'm leaving forever. So therefore, I was not an emigrant. In the UK, the moment I stayed in the UK for more than 12 months, I was considered an immigrant. So I'm immigrant here, but I'm not immigrant from Poland. That already shows you well, that's actually a definition, but underreporting is when people actually neglect the registration. So I'm still in the UK 11 years now, but I never actually went back and deregistered myself. So I'm still considered a resident in Poland, technically. Another issue with data is accuracy. So if there's a population register or census, they typically capture the entire population. So there's no big problem with accuracy. However, some errors occur. The errors occur when we use a survey to capture population, and that's done in quite a few countries who use large surveys to calculate the stocks of migrants, for example, on a yearly basis. The last issue is a timeliness. There's always a delay between data collection, processing, and publication. Usually, for example, in Eurostat, it's about 22 months. I think they try to shorten that period, but typically it's about 22 months. Of course, censuses come every 10 years or every 5 years. The recent census was 21st of March this year, and the results will be revealed on 21st of March next year with the full data available. I think it will be within 3 to 5 years. So that takes a lot of time. So we want to know this. The problem is that we would like to know what's going on with the migration and with population change on a more regular basis. So this is coming back to the data availability and comparability. These are migrant flows for biggest countries in the European Union and for the UK. And we can see, and this is technically 2019 data, which should be standardized to a common definition of being in a country for a migrant who spends in a country more than 12 months. As we can see that there are lots of gaps. Some countries, okay, and the data are reported either by sending country. So for example, from Spain to Italy, it can be reported by sending country, by Spain, or by receiving country, by Italy. And we see that even though those data are technically standardized, what is sent by the Statistical Office of Italy as a number of, by the sending country, but the Statistical Office of Spain does not match what is sent by the receiving country, Italy, even though they should technically be using the same definition. It's almost twice different. Yeah, there are some even big differences here. Italy to Spain, for example, this is the same example, same case. There are also lots of gaps in the data, as I mentioned earlier. So this is the issue with, even when the data technically coming from the same definition, we still do not have the exact picture of what's going on, because this data are not directly, they are technically comparable, but they are not the same. Okay, and the other part of the data is migrant stocks, and that's what I will be talking about today. So these are the migrant stocks born in country I, residing in J. This is directly from Eurostat. We see, for example, many countries, they don't report this data. This is 2017, and there are also various gaps for previous years. On top of that, there are some minor differences in definitions, such as countries using this qualifying duration of stay in a country, such as 3 months versus 12 months for considering who is a resident. But I'll leave it aside for now. Okay, let me move to the methods. So I will deal with that problem. I show you a model that we developed, my colleagues and I developed to harmonize those data and use some new forms of data. But first, let me jump to the methods and give you a brief introduction or a reminder of things from the probability theory and statistical inference. So first, just very briefly, I'm sure you're familiar with those concepts, although I'm not teaching the students mathematics, so I'm not 100% sure that what's exactly covered there. But again, I'm not showing any thorough and rigorous derivations. I'm just showing ideas and concepts here. So we can talk about probabilities in different definitions. There are different definitions of probability. One of them is a theoretical, so-called theoretical probability, where we consider some hypothetical examples, such as rolling a die. For each, we define that each side has a probability of being rolled, for example, 1/6, and that's all very nice, and that's how these probabilities work in theory. The second definition of theory is a frequentist approach to measuring probabilities. Is when we, for example, the probability is measured as a relative frequency of the repeated experiment. So, for example, we are tossing a coin multiple times, and then we are estimating the probability as being as the number of, for example, heads obtained after n flips against number of experiments, number of tosses. So if we go to infinity, we'll obtain this estimate of the probability, which is in a frequentist interpretation. So we use those proportions of success over a number of experiments to approximate the underlying probabilities. And the third probability that I would like to highlight today is a subjective probability. Bruno Definetti famously wrote in the beginning of his very great book that probability does not exist. It's in the eye of the beholder. So there is no probability somewhere out there. That's how I at least understand it. It's in my head, it's in my mind. When I'm not sure about something, I create this probability in my head, creates the probability in my mind about some events that I am uncertain about. That was suggested by Dennis Linde, that it's a measure of belief, whether I believe that it will rain tomorrow or it will not rain tomorrow. That's such an event. Or, for example, we can talk about things that happen in the future, such as rain tomorrow, or things in the past, such as Shakespeare wrote Hamlet, or someone else wrote Hamlet. Those probabilities, yeah. How certain are we about that? Have we seen Shakespeare writing Hamlet, or have we heard that? How much do we believe in that? So this measure of belief is underlying the so-called Bayesian inference, where we update those prior beliefs with the observations to create so-called posterior distributions. So we have a prior belief, which we think that it represents some values of, for example, unknown parameters. We gather evidence and we create a posterior distribution for the unknowns to learn about that. I'm not going much into detail about how to obtain those posterior distributions and how to work with technically with that, but I just flag here that the computational methods relying on Monte Carlo simulations are very rife and widely applied in Bayesian inference, especially in applied work, applied research. I believe actually that you have had a colloquial, one of the lectures was covering the Monte Carlo methods, and just usual algorithms used here include Metropolis Hastings or GIPS, implemented in software such as Barks or JAX, just another GIPS sampler, or Hamiltonian Monte Carlo implemented in a software probabilistic programming language, STAN. There's also approximate Bayesian computation, but I'm not an expert in that at all. So I'm just flagging this up that this is widely used in applied Bayesian inference. So what is this Bayes theorem? Just a reminder from the definition of the conditional probability when we have a joint, when defined probability of A given B is a joint probability of A and B divided by the probability of B. We can define probability of B given A, and from that we can easily derive the Bayes theorem. The Bayes in this Bayes theorem, when we have a probability of A given B, it's equal to the conditional probability of B given A times marginal probability of A divided by the marginal probability of B. We can replace those A's and B's as some theoretical events into the parameters. So, for example, theta can represent unknown parameters of the statistical model, and X represents data. And now, the Bayes theorem says that the probability of those unknowns given observed data, given observed evidence, is the probability of data given a set of parameters times the marginal probability of the parameters divided by the marginal probability of the data. So theta is a vector of these unknown parameters or unknowns, and x denotes the evidence. This probability of x given theta is a likelihood or a model for the data, which basically denotes the probability of a given that we observe this x given set of possible values of the parameter theta. P of theta is called the prior distribution for the parameters, and the P of x is a marginal distribution for the data, or it can be also considered a normalizing constant. Yes, a normalizing constant. Therefore, in Bayesian inference or in applied textbooks, for example, you will find this notation of a proportionality. So probably the posterior distribution of theta given evidence is proportional to the likelihood multiplied by the prior, which can be expressed, which is basically the interpretation of that is the probability of the unknown given data is proportional to the probability of the data conditioned on the parameters times the prior distribution for the unknown, so our prior belief of that. So what's the difference between this frequentist or Bayesian inference? The frequentist approach evaluates the accuracy of an estimate of an unknown value in terms of how different this estimate could be. So the parameter, the unknown value, is fixed. We only estimate this accuracy, how different it might be if we had a different multiple samples, multiple repeated experiments. In Bayesian approach, we update our beliefs about the true unknown value. We call it true, should be in quotation marks, which is the parameter or prediction, should be or prediction. And our beliefs, those beliefs about the unknown, are expressed using probability distributions. So the unknown values always have a probability distribution, and they are not fixed. Yeah? So let me just show you a very simple example. So let's assume we have a random variable which is coming from which is distributed using a binary distribution. So we have n trials with a probability of success being theta, and the likelihood is defined as given by this function. The prior, which is conjugate and allows an analytical solution of this, or analytical derivation of the posterior distribution, is a beta with hyperparameters a and b. So the beta distribution has expectation of a divided by a plus b. So it is a defined, I should have said, this is defined on a 0 to 1 support. So basically it's a good distribution if you want to represent our uncertainty about the proportion or rate of success. So the posterior distribution can be easily derived from this by multiplying this likelihood times the prior to obtain the posterior. And so, yeah, to obtain this posterior, and as we can see that this posterior is a beta distribution where this parameters of the, for example, expectation is the weighting of what would have been, how many number of successes have been observed, plus our initial belief about this number of successes. And this is the second parameter, which represents the number of failures. N minus x is, so x is the successes, and n minus x is the number of failures. Yeah, so just by plugging into the expectation, we'll find out how the prior modifies the posterior in comparison with what has been observed. Whereas in the frequentist approach, our estimator would be x divided by n minus x. That would be sorry, the estimator, yeah, that would be that would be x over n. That would be the estimator of the parameter theta. So I mentioned that we can work with conjugate priors, which allow analytical derivation of the posterior distributions. And those conjugate priors, but also non-conjugate priors, which cannot be actually used in more complex models because that's basically analytically intractable, and they rely heavily on entirely rely on the sampling algorithms can represent those beliefs. So let me show you some types of priors that we may be using. For example, these are some weakly informative priors about our success rate. This is completely flat prior, which says that I'm completely indifferent about what this rate might be of success between 0 and 1. This one assigns a little bit more probability mass to the middle of the around 0.5, whereas this one shows that I'm a little bit, and I believe that it's rather not in the middle, but more likely to be in the either close to 0 or close to 1, so either failure or a success. This more informative priors here, or very informative prior here, show my degree of belief that the rate of success, the probability of success is 0.6, quite sure about it, or a little bit less sure, but still centered around 0.6. This probability, this prior distribution is fixed at 0.6. That means that this is what I believe. It's 0.6, and that's it. In this case, no evidence will change my prior. Okay, so that was a very brief introduction, a reminder of the Bayesian inference. Now let me move to the modeling framework of the model that my colleagues and I have developed to harmonize migration statistics. Sorry. Okay, so let me start with the data that we actually used in the model. First, we used the data from the official data reported to Eurostat, the ones that I have showed you earlier, this data. These are the data that are sent to Eurostat by the statistical offices of the European Union countries, and until 2020, they also have been sent by the UK. Actually, they are sent after that too. It's just the matter that the UK is no longer in the EU, but the data are still available there. So those data, for the purpose of this project and this presentation, they contain the UK, because historically UK has been part of the European Union. And about 45% of the data from the population registers are missing. Yeah? So quite a lot, only a little bit more than half are available. Another data source that we used is the population and housing census of 2011. And censuses in demography are considered most valuable, the most accurate data sources that we can have. However, I apologize for this mismatch here with the timing. However, 21% of those data available in Eurostat are missing. It might be for various reasons, because, for example, some countries do not meet the criteria that sense that Eurostat asks to be fulfilled in order for the data to be shown in their official database. So this project has been prepared for the European Commission, and they request us to use the official data as reported to Eurostat. The third data source is the EU Labour Force Survey from 2016 and 17. And this data have lots of missingness, and they have large sampling errors because, for example, when we try to measure this bilateral number of migrants living in other countries, there might be quite a few observations, only very few can be captured. So that leads to large sampling errors. And also lots of data are missing. You might ask why we use those data. It perhaps might be because we are still filling some gaps in those data not reported from official sources, or some not available in Eurostat. And finally, we used new sources of data, which is from Facebook advertising platform. And let me just explain to you in more detail what that is. So Facebook data are publicly available aggregate data through the marketing API. So if you would like to if you have a Facebook account, and if you would like to have a produce an advert for Facebook users, you can freely access those data, and actually you can gather information programmatically through their API. Why those data are of value in migration studies? Because in Europe in general, there are about 423 million monthly active users as of first quarter 2021. In 2018, so that's the time when we were doing the research, in the EU alone, there was about 250,000, which is about half of the EU population. So that's quite a lot, quite a good coverage of the EU, of the population. Migrant stocks can be defined as there's a category called lived-in, so-called expats, and these are defined by Facebook algorithm, which is unfortunately black box to us, via current city and hometown, and also as self-reported by the Facebook users, and validated based on their device, on their connection, and importantly, on the social network. So if I'm saying that my hometown is somewhere in Poland, but I don't have any friends from Poland, that I would not be considered a migrant who used to live in Poland. I don't know if I have much time. I actually could show you how this works in practice if you are interested. Can you see a website, Facebook website now?
No, we only see your file.
Okay.
So probably you're sharing.
Yes, I'm probably sharing the screen. Give me 1 second. I just changed that very quickly. So this is a Facebook business account. Anyone can have it. And if you create, and I apologize, I think there's might be some Polish language somewhere here hiding. But the issue is, sorry, if you just open this business account ads manager from Facebook, you will be able to create a fake campaign, and then you can search for your audience. So for example, I have been searching here some audience, and I will now look at, for example, United. Apologies. Just type in United Kingdom. Yes, so I'm looking at people who are in the United Kingdom, aged 18 to 65, all genders, and now I have detailed targeting, and I can just type live in Poland, say. So I'm targeting those people in the UK who are aged 18 to 65, all genders, and live in Poland, and now Facebook will show me that my potential reach is 360,000 people, and this value is the estimated size of the audience, which is the monthly active users. If I'm accessing the data programmatically, I can also access that in a daily active users, which is prone to more volatility, but it may be more accurate if I want to have more data simply. I can also search for other, for example, other countries, be it in Germany, and I will see that now changed to about 31,000. So that's how I can obtain information from Facebook. Of course, when we did the project, we didn't click it everything. We used the API. Okay, I'll now move to the slides. I hope I explained what I mean here. Yeah. So gathering those data also, it takes time. Mainly because there's no retrospective collection. So if I want to use those data in my research, I have to be gathering those data as we speak. And usually we do it in some short windows when we gather data within 1 day, and then the next month we collect another set of data, etc., and then we average them. Another limitation is that it's really difficult to define what an expert is based on some scrapes of information really obtained from Facebook and Facebook employees. Another key limitation really, but we try to actually handle that in the model, is that Facebook usage varies between countries and subpopulations. So in some countries there are many users, in some countries there are quite fewer. For example, I think UK is quite wide use of Facebook. I think Germany and Poland has the lowest in the EU at the time. There's also censoring, which we also account for in the model, but I'm not talking about that in detail, which is that the observations are truncated at the 20 for daily active users and with 1,000 for monthly active users. So if the potential audience is less than 1,000, it will be just rounded up to the nearest 1,000. And the missingness here is for monthly active users, 42% and 19% for daily active users. That's why we decided to use this more volatile, but potentially more widely available data. Okay. So let me move to the migration model, which is the key of the talk. So we define those, we denote these migrant stocks, observed migrant stocks data as Z. They are born in country I, reside in country J, and the data are reported by source K. And we have sources Census 2011, Eurostat, Labor Force Survey, Facebook monthly active users, and Facebook daily active users. So we see that there are zeros on the diagonal. That means that we are not really considering the nationals living in their own countries or people born in the UK living in the UK. That's not part of the model. We are only interested in migrant stocks. That's why there's a zero on the diagonal. And now the key point of the model is data harmonization. So we account here, I mentioned to you earlier that we have these differences in definition, in coverage, in underreporting, and in accuracy, and in timeliness. So timeliness is not something that we can actually deal with easily, but that's why we are using the Facebook data, because they can be collected today and they represent situation today or for the last month, last 30 days, rather than 22-month delay of official statistics. But coverage, underreporting, it's really difficult to distinguish between the two. Therefore, we created one parameter, which is called bias. We call it bias. And this is a bias specific to the source, and it can be specific to each of the migration, what we call migration corridor. So number of migrants from I living in J in year T. And then accuracy is really a margin of error or variance of the assumed data source. Yes. And the key point that I'm trying to reach is that those data represent the true migration or the true number of stocks of migrants. So the data, if in a perfect world, the data are equal to true migration. However, we're not in a perfect world. We have those issues with migration, with data collection, data measurement. So the true migration is biased. Sorry, the data. In order to, so the data are biased, so we need to correct the data for the bias, and we need to correct for their accuracy. And that's how we are having this latent or unobserved parameter in a model, which is called true migration from country I living in J in year T. And as you can see, this actually is not specific to a source. There's one true migration, and data from each source, they can have different bias and different accuracy, but they all should be reflecting the true migration. It's like Plato's light in the cave. So we're seeing that there's some light, some reflection on the wall, but we don't know what the source exactly is. Okay, so this is the modeling framework in a graphical representation. So we have this. We have a 3-level model, the 2-level model, where we have the data. Each data source have their own accuracy and bias parameters. So this is Labor Force Survey, Census, Eurostat, Facebook, and they all measure what we don't observe, which is the true stock, the unknown number of migrants. And then we have a migration model that imputes the missing information. So it's not only that we harmonize those migration statistics from various sources, but we also have to impute the missing information. So how do we do that? First, the measurement model. So each data source, as I have shown you in this equation, each data source, we assume a log normal distribution or a normal distribution for a log of the data. So when there were zeros, we had to add a 1 to all of the observations. That's a dirty trick. And they represent the true flows corrected for the bias. And that's represented by the parameter gamma, which is specific to census. And this is, as you can see, there's only one parameter for all censuses. And that's the potential bias either underreporting or coverage issue. For Eurostat, we actually use a grouping of countries. So we assume that from the past projects and from the expert opinion, we also learned that some countries have quite low undercount, quite good coverage, and there are some countries which actually do not have that. And we group those countries, and we just, for simplicity, use only two groups for low and high bias in Eurostat data. The labor force survey is more specific to the is specific to the country in where the labor force survey is carried out and in a year, and we tie these parameters to the information from the user guides of the labor force survey. For example, whether the questionnaire is obligatory or it's whether it's compulsory or not. So if it's compulsory, we expect that it will be smaller bias, and also some other measures such as quality of the survey and the numbers and the sample sizes in comparison to the population. For Facebook monthly and daily active users, we also use this bias, and here we tie it very explicitly to the number of Facebook users in the entire country. So we can calculate how many users there are in a country, such as I said, UK, there are quite a few users. I think the best countries are, I think, Cyprus. I don't remember the other, I think the other ones. And the least users, about 50%, are in Poland and Germany. In terms of accuracy, this is denoted by, this is a precision, so it's a reciprocal variance, 1 over variance. And those precisions are also either constant for all of the data, or for example, for labor force survey, they can be specific to the corridor, to the exact corridor and year, because we may know actual uncertainty about measuring migration from the survey. So let me explain a few words about this prior distributions, about which I've been talking about earlier. So how we express our uncertainty about those data sources and their problems by using prior distributions. So the prior for the bias parameter, for the gamma parameter of the census, is a normal distribution. So as you have seen here, this is a log of gamma. Yeah, so on a linear scale, when we multiply those expectations, this will be a multiplicative component. So it has expectation of 1. That means that we assume very small bias with quite large precision. So the variance is open or 1, and this is on a domain from 0 to 1. So that implies very small bias on average for all census data. That's what we believe is the case. For Eurostat, we actually remove this domain 0 to 1, and we say that Eurostat bias is around 1 with the same variance as census. And why? The question why we don't assume that there's possibility of bias. We actually imply that there might be some underreporting as also overreporting. That's because people, when they don't deregister from a country, they are still counted in the population. That's actually over counting of the population. And we let the data by comparison learn from the, sorry, we let the model to learn that from the data by comparing various data points from various countries. For the Facebook, as I mentioned earlier, this parameter depends on the usage of Facebook in a country and in a year, and also on the grouping of the countries. So we have countries with many users, we have countries with fewer users, and that's how we create this parameter. For the precision of the or the variance of the data, we use, this is just examples of the priors, but I'm just trying to explain to you how what's the reasoning behind that. So for the precision of the census, we use the normal distribution at the center at 5,000 with very small actually with quite a bit of the precision. I apologize. I'm now not sure whether this is actually precision or variance, but let's focus on this 5,000. So the 5,000 assumed for the census, this should be actually a normal distribution that defined on a 0 to infinity support only, because that's what precision can only take. That's the values that precision can take. And this 5,000 implies the coefficient of variation that is the standard deviation. Sorry, that's the standard deviation divided by the expectation of the distribution of about 1 over square root of 1 over 5,000, which is about 0.014, which is about 1.4% in terms of the one standard deviation from the expected value. So we can say that there's very small error, random error in accuracy of the census, amounting to 1.4% in terms of this coefficient of variation. So that's the very nice feature of the log normal distribution, assuming a log normal distribution for the flows. Sorry, for the data. For Eurostat, as you can see, we have a smaller precision. It's 1111. I apologize, it's a mistake. It should be 1011 here, 111, which implies that the coefficient of variation is about 0.03, which is 3%. So in relation to the census, the Eurostat administrative data are about twice less accurate, but still 3% accuracy, plus minus 3% accuracy in terms of the standard deviation from the observed value is quite large accuracy. For example, for the Facebook monthly active users data, we use this prior coefficient of variation is about 14%. That's much larger. Yeah, of course, this is only approximation, this coefficient of variability, but it works well for the small values, doesn't work well for the larger values, but still for even for this one is quite reliable. So these are the priors that we use in the model. So here we have a prior for the census. This is the bias prior distribution. It's very close to 1, but we assume that so it's not a bias, it's the 1 minus bias. So that means that the data are from the census are quite accurate, whereas data from Eurostat can be both leading to both over and undercount. For Facebook, we have those groupings, whether this is monthly or daily active users. And for labor force survey, we actually assume that they are quite poor in capturing migration accurately, which means that they have quite large sampling error. So there is an implied accuracy of the sources from high to lower, being the lowest down, the daily active users. And for the labor force survey, actually, this is quite interesting thing, which I'm not explaining in great detail here. But if you start analyzing survey data and look specifically for the number of counts that are captured, such as number of migrants, you will notice that when you have small number of migrants captured, you actually end up with higher uncertainty than when you're capturing large number of migrants, or it can be any type of subpopulation. So here we are dealing with the under dispersion. That is the larger number of counts imply larger accuracy of the number of people captured in the survey. So we introduce a prior distribution that is tied to a linear model where we use the data to inform the prior distribution for the precision in a way that we impose this coefficient, the slope b, to be positive. That is that the larger the flow, the larger the precision. And those parameters a and b have their own priors, and we estimate them in the model. Okay, so I explained the measurement model, so-called measurement model, so how we correct the inadequacies of the data, but we still have lots of missing data that we need to estimate. And in this particular case, we use a hierarchical so-called migration model, which in this case is a very simple autoregressive model in which we tie the current value of the true stock born in I, living in J, near T, to the value of the true stock on the log scale born in I, living in J, but a year earlier prior to that. And this is again this is an autoregressive process with the parameters specific to each migration corridor, so IJ specific, with the priors that permit in principle the borrowing of information between countries. So if we have information from some, we learn about those parameters in some countries and use and impute the missing information in other countries that do not provide data. So these parameters beta 1, beta 2, ij specific, they have a bivariate normal distribution with the expectation being mu b1. Yeah, so that's fixed, not ij specific. And this should be actually beta 1 and beta 2. I apologize for this mistake. And the hyperparameters for those for this parameters is a bivariate normal distribution 10, 0, and standard normal distribution, but standard normal bivariate distribution, with the priors for this precision being also the truncated normal distributions. The 10 comes from the average on a log scale average size of the migrant stocks, which was purely for the computational, was introduced purely for computational reasons. Okay, I see that I should be coming close to an end. So let me move to the results. Now, yeah. So this is this plot shows the total European Union mobility stocks for people aged 15 to 64, and it shows all EU movers, those people who were born somewhere else but now reside in a country that is different from their country of birth. These are our estimates, and for 2019 we estimate that there are about 15 to 16,000, sorry, 16 to million people of those migrant stocks. And now, how does it compare with the data that we used for estimation? So this is this Eurostat data, and as we can see, this is much lower. And the main reason for that is not actually any kind of a bias that we have been trying to correct for, but rather the missingness of the data. As I mentioned to you, that we only have 55% of the data available. So this represents the other 45 that are missing. These are the census data. There were also about 20% of missingness in the census data, so this is not perfectly matching. However, it is much closer to what was observed in 2011. And then we have other data sources such as Facebook data. These are the data from 2016 and 17, and there's quite variability here because we also have missingness in those data, because those data have not been collected for this particular project, but so for some other projects, and they did not cover all of the countries. Only 2019 actually should be covering those. 2018 and 2019 should be covering those countries. There's another issue here that actually you may spot. It's a big difference between 2018 and 2019 Facebook monthly active users or daily active users. And this is because Facebook is a black box, and for some reason they introduced a change in their algorithm that calculates the number of migrants, which we corrected in a model that I'm not paying too much. I'm not showing you exactly how we physically recalculated those biases specifically for each year. So moving to the more specific examples, this is migrant stocks in the Netherlands and in the UK. So what's the advantage of using this combination of the data? So for example, in the Netherlands, we have the data observed in the Eurostat that very nicely fall within this predictive 80% predictive interval. This is the posterior distribution of the total number of stocks, the true Y, say in 2013. And this is the data reported in Eurostat in 2013. And it's falling very nicely close to the median of the posterior distribution, and it's and also captures the trend. Our estimates also capture the trend. For the UK, on the other hand, we don't have those data reported in Eurostat. So some countries, actually quite a few countries, they do not report the exact breakdown by country of birth or country of origin, where their migrants come from. They only report whether they come from the EU or not from the EU. And UK is one of them. We have the census data here, and that shows that our estimate is really precise. It's a very narrow predictive interval here. But for the data for the years that we don't have any data, this is imputed. And here we see the uncertainty of the imputation. For years when we have some data, such as labor force survey or Facebook, we observe that uncertainty is narrowing down. And we are also able to predict the 2019, which at the time of this research was only available from the Facebook data. So we are able to capture this, any potential sudden change in the migrant stocks. It shouldn't be great, technically, but anyway, we are able to produce this estimate for the 2019 for when other traditional data sources are not available. Yeah. Also, to further assess the model, we also run several different validation tests and the posterior predictive checks, which came quite well, which looked quite well. But we also did a sensitivity analysis, which I think is the more interesting here, which is we have been removing at random various portions of the data that are input to the model. And these are the different scenarios that we have considered. So removing Eurostat 10%, 20%, 5%. We only fixed the results at 2016 estimate. We run a model without Facebook data, and we run a model relying only on Eurostat data. So only Eurostat data is quite extreme scenario. As you can see, there's a huge variability, huge uncertainty here, and inclusion of other sources of data reduces this uncertainty dramatically. And we can see that while there are some there are some differences for those particular countries, they are not dramatic. The results for these countries are quite robust. The largest difference, of course, will be observed for countries for which we have the least information. We can also create estimates for the entire, for different countries, or for whether it's emigrants or immigrants. So this is an example of emigrants from Poland. Poland don't have from Poland, yes. So, and the red squares denote the Eurostat data. So these are the data as reported by countries to which Polish migrants have migrated and reside there. So, for example, Germany do not report such data, UK do not report such data, and they are the biggest recipients of the Polish migrants. And we can see that this uncertainty here is the largest, except for those years for which we have some data, such as labor force survey, available. For other countries where we have those data, it's actually showing on a linear scale. So it's not very well visible what the actual patterns are, but we can see that the uncertainty is much, much lower for those countries. So this is the stylized map of the Netherlands, sorry, of the European Union. And I think in the Netherlands here we can see that there's quite few migrants there, not as many as in Germany or in the UK, but we can see that the uncertainty is much, much lower here. So to discuss points that you may want to discuss or you may want to ask about is in the limitations part, but I just would like to summarize that those timely Facebook data that can be obtained here and now, rather than waiting for the official data, they can be combined with the available Eurostat and other data sources and benchmarked to the most reliable data sources. The Bayesian inference and the representation of uncertainty by prior distribution is the key to obtain those estimates to harmonize migration statistics. And those data, again, provide a wider picture of the EU mobility that can be applied to other countries. That's what my colleagues and I are working currently. And they, because of the use of Bayesian inference, they all come with measures of uncertainty, and they are explicit and easy to interpret in terms of probability distributions. So the main limitation of this work is sensitivity to the results to subjective priors. So actually, when we change those priors, the model will produce different results. So that's why we rely heavily on them, and that's why the representation of the expert opinion is crucial to the success of such a model. Another limitation is inconsistency of definitions. So I told you that Facebook has their own definition. It's not country of birth. we acknowledge that, and we believe that this is actually represented by the quite wide uncertainty predictive measures. And we also have lots of missing and censored data in our model. It's not maybe very sophisticated, this autoregressive model that I have showed you earlier here. There can be some other models, such as theory-driven models, can be used to impute that. But the point here was also to produce forecasts of migration, and we relied on as little external information as possible. So that I finish now talking about migration. I just give you some points for further reading. If you are interested in applied statistics and applied Bayesian inference, I recommend the books by Joseph Cadane, Principles of Uncertainty, or Mark Ellereth's Statistical Thinking. It's a really good book, and it shows you examples in R and STAM. This is a probabilistic programming language. If you would like to learn more about migration, this is a paper that my colleagues and I produced for migration flows. So that was underlying the model that I'm presenting you today, which is for migrant stocks, and that was produced a bit later, and with some changes as you have seen. So if you have any questions, here's my email, and I also acknowledge funding for this research that I presented to you today. So I'm awaiting your questions and comments. Thank you.
Okay, thank you very much, Eric. Let me just first stop recording.